So in collision, so you go back to the basic idea of collision. So we know a particle moving with a velocity u, it goes in, collides with a wall. This is a fixed wall. After collision, let it rebound with a speed u. Then what is the change in momentum? 2mu will write it. Then that collision occurs for certain duration of time. So therefore, definitely the force exerted by the wall on the particle or by the particle on the wall should be delta P by delta T. Shall we bring the idea of the force like this? Rate of change of momentum should be the force. So will this particle exerted any force on the wall? Yes, it is. Similarly, the wall exerted any force on the particle? Yes, it is. Same thing shall we go for photon, because even if there's a surface, the photon will be associated with a momentum, and the momentum of photon is how much? H by lambda. If the photon is reflected back, then will this photon will exert any force on this? Yes, it will be. The change in momentum of photon per unit time should be the force exerted by the photon on the wall. So earlier for particle, no, his surface perfect, so like a perfect absorbers. So black body. If a radiation is incident on a black body, the black body what will absorb it completely. So their surface can absorb photon completely. Similarly, instead of this, the photon is incident on a surface and it is absorbed completely. Then also happen, there'll be change in momentum. In this case, what is the change in momentum here? 2h by lambda. Get this one. So in this case, what is the change in momentum? H by lambda. I think it's not question of one photon. No? When a beam of light is incident, when you go for beam of light, definitely millions of photons will come and strike. So continuously the photons will be striking. So the number of photons striking, the change in momentum per unit time will become the force. So I'm just slowly building up the idea from here. Due to change in momentum per unit time is the force. So here the photon is reflected. Here the photon is completely absorbed. This photon now will exert a force on the wall, or so like on the surface here. Rather than saying wall, call it as surface. So continuously the photons will be incident. So continuously the photon will exert a force. So continuously there will be change in momentum. The change in momentum per unit time is what I'll get expression for force. That force per unit area will become pressure. That pressure I'll call radiation pressure. Able to make it out, this one? So now how to calculate how many photons are there in a beam of light? I think already we have made some background in the photoelectric effect. If a beam of light, if a beam of light, just initial derivations are a little bit difficult for you. Once you get that formulas, no, the rest of everything is application, very easy, that one. So as we assume that it contains photons, and these photons, the associated momentum, let lambda be the wavelength and let I be the intensity of the beam. So this is beam of light. How many photons are, let area of cross section of this beam, let it be area of cross section of beam, let it be E. How many photons are present in this beam? Can we calculate? For a beam also I brought formula. Can you recollect here? Basically, number of photons should be the power of the beam by the energy of photon. What earlier we had power by energy of photon, the same thing, power of the beam by energy of the photon. Before that, what is the intensity? I think we should have a basic definition clearly. Intensity we define like this. energy flowing per unit area per unit area per unit time normally. Energy flowing normally per unit area. I'll bring normally here. Normally per unit area per unit time. That's the basic. I think it will go like this. U energy that is flowing per unit area per unit time. This energy flowing per unit area flowing normally per unit time is what we call power. Any strict condition, this power, this should flow normally through the surface. So that energy flowing normal, power flowing normally per unit area will become intensity and the with the sun. So strictly that flowing normally is very important. I think already in waves and sound we have come across. So we used to define like this, no, the intensity, energy flowing normally per unit area per unit time. Similarly, how many photons are emitted by the source? Can you remember this? Power of source by energy of photon. Power of source, let it be, and this will be hc by lambda. Now, how many photons are present in a beam of area of cross section E that is having intensity? Because what is the power of the beam? Let's call P, or P naught you call it, because power P, again you'll get confused with the pressure. So how many photons are present in this beam has to be calculated. So shall I go for the same thing? Number of photons flowing per second or moving per second, anything it will be. So that I'll call N. This should be equal to power of the beam by energy of photon. Agree this? So P naught, let me keep as it is. Energy of photon is Sc by lambda. So P naught lambda by Sc. Now, what is intensity of a beam? We define like this. Power flowing normally per unit area. So this I'll write it as Ia lambda by Sc. So this will give number of photons incident, or better say than flowing, or number of photons flowing per second through that area, the area of cross section. How many photons per second will cross through that like a area A is given by this particular formula. Okay, the base of this entire, the whole chapter, radiation pressure. So it all depends upon the area of, A is not amplitude, huh? Area of cross section, area of cross section of beam A. The wavelength of the light, intensity of the light, HCR constant. This will give number of photons flowing per second. I think per second is very important. Okay, now this particular beam of light is incident on a surface. That surface is going to absorb this beam. Let me put. So rather than beam now, so let me go for a surface here. So I'll keep a surface. So let this be the surface here. What is the, look at the surface? It's having area of cross section E, which is less than the area of cross section of the beam. So I'm now what shall I do? Number of photons incident on a surface per second. So shall I the same formula? Area of cross section of beam is earlier. See, beam can come out with of any area, no? So if the area of cross section of the beam is less than that of surface, then area of cross section of beam you have to take it. If area of cross section of the beam is more than that of surface, then in the formula here you have to put area of the surface here. Now you have to be careful here now. What did you see? Here area of cross section I defined it. Now look at the area of cross section of the beam, more than that of that one. So now only a part of beam will be incident on surface. No, now this A will become area of surface here. So these are the photons. The photons are here. Let the surface absorb the incident photons. Is it all the photons are incident? No. Only the one which will lie in this region are incident here. So this is surface absorbs the photon. Then the photon, it was having momentum. There's a photon. I'll put like this. So what is the momentum of this photon? H by lambda. The momentum of this photon is h by lambda. So the momentum of photon is what? H by lambda. So then the photons, what happened is absorbed. So it was moving, and finally what happened? It will lose all its energy. Once, so what happened? It loses energy. That one, no question of photon itself is existing. So what happened? The momentum of photon changed here. So how to calculate that particular force? So this is what number of photons incident per second. So how to calculate the force exerted by the incident beam on the surface is, the formula will be F is equal to change in momentum of photon into number of photons incident per second on the surface. But we know change in momentum is dp, no? From where to bring that time, I think we have here number of photons per second, no? This is, so I'll multiply what is the change in momentum, h lambda, h by lambda. This is a change, it is the absorbed, no? It was moving and came to rest. What is the change in momentum? H by lambda. Then what about the number incident per second? So Ia lambda by SA. This is momentum is there here. Number of photons incident per second. So change in momentum into number by per second. So I think that should be the force only. H by lambda get cancelled. So I'll get Ia by C. What is AE now? Area of cross-sectional surface here. Now the force exerted by the incident beam per unit area will become radiation pressure. How do this force will act? Normal to the surface. This should be, so this should be equal to I by C. This is called like a radiation pressure. I think this approach will help you a lot in numericals. In some books they have shown by another method. So okay, fine, definition wise okay, but numericals when we go, no, because we'll take again this numericals back to the mechanics, because there's a pressure force, no, so I'll bring all the mechanics problems. This force, can it make the body to accelerate, or just only theoretical thing? Yes, this force can accelerate a body. So with a beam of light, can I make a block to move? Yes, I can make a block to move. Now let's introduce here only so that you'll get very good application problems. So there's a block of mass m I kept here. So then a beam of light is incident. There's a lambda. I think only lambda is needed, no? And the intensity is needed. Lambda also not needed. The intensity of beam is I. Area of cross section of block, let it be L. That one, side length is L. So clear this. So how do how do you confirm that there will be a force acting it? Let me keep it on rough surface. I can measure friction by some means. What I see that I can notice that a friction is acting, and it's at rest. So from where this force is coming? So definitely the incident beam. This is beam of light. This beam of light is what? Exerting a force. How to calculate that friction? So we know, so this will be, it's a test static friction, it will be acting here. So the force exerted by the radiation, this should be equal to Ia by C. I'll keep on increasing intensity. At one particular intensity, the block starts moving. So this shows that there's some sort of like this beam is exerting force, no? First, initially, for lower intensities, so when the block will be attached. As I keep on increasing intensity, the static friction will also increase. So once the friction acting, the applied force becomes greater than limiting, no, the block starts moving. So this shows that this particular beam of light, which is incident, is exerting a force. So we are assuming that it will absorb. Look at C. Look at C. What is C? 3 into 10 to the power of 8. 10 to the power of minus 8 will come. No. What is the intensity of beam? 1 watt, 2 watt per meter square, 3 watt, 10 watt, 100 watt. That's all. No. 100 watt bulb we have in our home. And that too, the intensity of beam, there should be. It will be very small. Practically means, sir, is it sunlight exerting force on me? Yes. Definitely yes. Sunlight is exerting force on. Sunlight is exerting force on our apartment, sir. Yes. You are moving in a car. Sunlight is exerting force on the car. Yes, it is. It will be of, but we don't feel because the C is there in denominator, no, 3 into 10 to the power of 8. And intensity can be say like a 1 watt. And what is the intensity of sunlight on the surface of the earth? It's very of smaller, 10 to the power of minus 3, no? So definitely this force will be negligible. I'm just giving some hypothetical problems. If high intense beam, if you take it, no, then you can feel some sort of, you can move that particular block here. You can see in the movies, no, they will, without in contact, they will push it. From where they'll push, I think in some Western movies you might have seen, no? So they'll push. So how do they able to push? Because of radiation pressure. So they will produce such a high intensity. Yes, maybe they have powers, mystic powers. This is surface absorbs incident photon completely. Absorbs incident photon. No. Next, after this, if it is a perfect reflector, so we don't have perfect absorber. This is again ideal because usually we'll get a surfaces which will absorb partially, which will reflect partially. And next, if it is same thing, if the surface, if it reflects completely, then what is the change in momentum? 2h by lambda. So let's take example here. So there's a beam of light. So let this be a surface. Area of cross section, let it be that one. So here the photons are there. So let me show that an incident photon it will get reflected. One of the photon, I'll just show it. So it will be reflected back. What is the change in momentum of photon? 2h by lambda. So directly let me go for the force experienced by this surface. F equal to change in momentum of photon into this will be number of photons incident per second, and there'll be incident normally. There's a condition. So what is the change in momentum of photon? 2h by lambda. This should be equal to how much? Ia lambda by hc. So this will be 2ia by c. So what is the radiation pressure? 2I by c. So like that, the incident light will exert a force that's called, this called a radiation pressure. So there's a beam of light. Why do we say mobile? We should not keep beside our head and sleep. It should be kept at a certain distance. Any reason for that? Because mobile will have antenna, and that antenna, what will happen? Will radiate power, and anything will happen. Yes, maybe the radiation will be incident. Of course, you look at the pressure, but you look at the cells, or you look at inside the cell. Or look at the brain cells, they are very sensitive no, here. So will it exert any force? Yes, it will exert a force. Will there be any impact on it? That's what the research is going on. But as such, what I know, the intensity matters a lot here. See the constant, the intensity is matters a lot. So just you keep some at a distance of 1 meter, problem solved. Mobile you can keep it in bedroom or so like in house anywhere. But when you are sleeping, because we sleep for 6 or 7 hours, that one. So for that particular long duration of time, we'll be exposed to intensity. So therefore, it's kept nearby it. It may cause some long-term damages to the health, that one. So therefore, just if you keep it at a distance of say like a half meter, that is enough. So don't keep nearby your inside below the pillow or beside that and sleep the mobile. Keep it just away. So the because it all depends on the intensity of the mobile. Because usually the if you keep nearby your head, yes, there is some problem is there. That to not one day like this continuously for 1 or 2 years. If you keep it every day, yes, there'll be some impact. There'll be some parameters come. So what type of disease will come? Will get a aftershocks, means like all of a sudden mood will change and you'll become hangry, then depression will start. So all that particular things are there. So still research is going on, but 80% of proof is there that yes, it will have some impacts here. So it's safe that not to keep mobile below the nearby the pillow or that one and sleep. Not advisable. Okay, this is about the when it is incident light is absorbed or reflected. There's a pressure here now. What happens if a surface both absorption and reflection? Because we'll never get ideal reflector, ideal absorber. Partially it will be absorbed, partially be reflected. This is something. Beam of light reflected. So next we'll go for next condition. It is partially absorbed, partially reflected. Incident light